Well, thank you, Vince. Yes, on my badge, I've been designated consulting engineer, but I spend all my working hours working for Rockwool International in Denmark. But I started my career, and I'm almost afraid of saying this because it's like putting a bullseye on my forehead, but I actually started my career in the group that developed the single burning item test. Beautiful. So I was very young then, so that's my excuse. So anyway, I can give you some of the history here of what went on back then. Later on, you can say, got the curse of having developed the single burning item test because I changed to industry. I worked for Rockwool International, and there I got involved in the receiving end, where we had to use the single burning item test in order to have the fire classification for our products for CE marking. So, revenge was sweet. Anyway, I'm going to spend quite some time today to talk about the history and the development of the SBI test, the philosophy behind the tool, because I believe this is very important. It was developed by 9 fire laboratories, which were called the official laboratories group, and they were nominated by 9 member states. What is very important to remember here is that the work of this official laboratories group was followed very, very closely by the European Commission's fire regulators group. So thereby, the SBI test is actually one of the only tests that's been developed partly by regulators. And this might explain some of the issues with the test. What is also really interesting is that CEN TC127, which is the technical committee within CEN, which is responsible for fire standards, was never involved in the development of the test. They were given the test after it was developed and approved by the European Commission. Then TC127 received the test to make it into the standard, go through the voting procedures, etc. So this is just to give you a little bit of that part of the background. Now, I'm giving a talk on the SBI test, so I thought I should include a photo of the test. But I must admit, I hadn't planned on giving any detailed explanation of the test, so if any of you want more detailed explanation, please come and ask me afterwards. All I want to say here now is that it is an intermediate scale test. It measures heat release, smoke production, flame spread, sort of, and burning droplets. And the size of the test specimen is 1.5 meters high. It's in a corner configuration, and one side of the corner is 1 meter wide, and the other one is 0.5 meter wide. And this here is from a test of a classic chipboard. Now, one of the very important steps in the development of the SBI was the very first round robin that we did. And for this round robin, there was 30 products chosen to be tested, and they were all chosen by the national fire regulators. Now, 30 products is quite a big amount of products. And the reason there was chosen so many for a round robin was that they were supposed to reflect what the SBI test should be capable of testing. So this whole group of product, it included anything from plasterboard, thermal insulation, sandwich panels, polycarbonate panels, cables, PVC pipes, all kinds of funny stuff. And that's quite interesting for a round robin to have that many products in it. So of course, one of the purposes of the round robin, like every round robin, is to show the repeatability and reproducibility of the test. But another very important result of this round robin was also that the test results were actually used to define the class limits of the Euroclass system. Because this is a new test, we did not have any class limits, so this was actually the way to have the results from these 30 products. We're going to define what is reasonable class limits. And before I get into that, I want to give you just a little bit about the Euroclass system. I mean, the Euroclass, I didn't bring the usual table of the Euroclass system as well. There I will refer you to the classification standard EN 13501-1. But I would like to say that there's more than the SBI test to the Euroclass system. There's a total of 4 tests. There is the non-combustibility test, the bomb calorimeter test, in the 2 highest classes, A1 and A2, the so-called non-combustible classes. And then in class B, C, and D, we have the single burning items, SBI test, and the small flame test. And class E is only the small flame test. Now I would like to go into a little bit about the basic philosophy behind the Euroclass system. And one of the better decisions made by the regulators when we started the development of this test is that the Euroclass system is linked directly to the perceived hazards in a reference scenario. So that was their principal thinking when we were going to start developing this test. So I'll try to somehow simplify this in a diagram. So first we have a real fire, right? Then we define a reference scenario that represents this real fire situation. Based on this reference scenario, we choose a large-scale reference test that models the reference scenario. And based on what Elizabeth just said, it would be nice to stop here with the large-scale test, but unfortunately they have a tendency to be very expensive, and poor industry can't afford these expensive tests, so instead we go to a small or medium-scale test that reflect the burning behavior in the large-scale reference test. So now we are back to what Vince was talking about, the model of the model of the model almost. Now the large-scale reference test, which was chosen for the Euroclass system, actually let me start with what the reference scenario was. That was fire in a room. That was the reference scenario, that was where the hazard, that was fire in a room. And the perceived hazard condition associated with a fire in a room is flashover. And I guess you all know why flashover is the perceived hazard condition here. And finally, for the large-scale reference test, the ISO 9705 room corner test was chosen as the large-scale reference test. And the nice photo over there to the right is a flashover from a room corner test of some kind of product which I've forgotten what it was. So, with this in mind, I was going to go back to my little graph from before, because now we can complete the picture, because the reference scenario, as I said, was fire in a room. The large-scale reference test is the ISO 9705. And the small, or should we say medium-scale test is the SPI test. And so in order to have the classification obtained in the SPI reflect the true fire hazard, or what we're seeing as the fire hazard of the product, the test result of the SPI shall reflect the burning behavior in the room corner test. And since the perceived hazard associated with fire in a room is flashover, the basic philosophy is actually that the test result in the SPI test shall reflect a product's propensity to cause flashover in the room corner test. This was the basic thinking back then. So that was a little of the history that you said you have problems finding there, right, Vince? Now, in order for this philosophy to work, of course we need to have some kind of correlation between the SPI and the room corner test. So in order to make sure that that was happening, all the 30 products from the round robin was also tested in the room corner. And the main classification parameter, which was chosen at that point in time for the single burning item test, was the so-called fire growth rate index, the FIGRA index. And the FIGRA index, I'll also refer you there to the SPI standard for detailed explanation, but I can just quickly say that it is the maximum of the function of heat release divided by time. Now, based on the FIGRA index, it was actually found that there was a really good correlation between the SPI and the room corner test, but only for 26 of the 30 products. 4 of the products, there was no correlation, and for these 4 products was, not surprisingly, pipes and cables, which is completely different scenarios. The other last 2 was polycarbonate panel, and then lastly but not least, metal face sandwich panels. So these 4 products were designated exotic products back then, and it was